Hello, my friends. Thank you for sticking with me. So, as you've hopefully imagined by the routine of this class, this is going to be an optional example video if you'd like some extra practice with the stuff we've been working on. So, what I'm going to do in order to try to tie together all the stuff we've done so far is to work through an example where we start with a production function and a wage and rental rate, and we try to build our way to a firm supply curve, right? So we know that this particular firm has production F of Lk equals the minimum of 3L and 2K minus 6, all to the 2/3. We know the wage rate is 30, we know the rental rate is 20, and our goal is to find the firm's supply curve. Okay, so where do we want to start with this problem? Well, to me, the best thing to do is to start by trying to work backwards, right? Given our goal here, try to think about what we're going to need to accomplish that goal and what we have to do with the information we have here in order to accomplish that. So what do we know about a firm's supply curve, right? What are we trying to get here? Well, we know that the supply curve, right, is the quantity that the firm is going to make at a given price P. And in turn, right, what we just learned is that if we think about our firm's cost curves, right, let's say that we had marginal cost like this, average total cost like this, right, our firm supply curve is just going to be our marginal cost everywhere above where marginal cost equals average total cost, right? Everywhere above the price where it's just worthwhile to produce. In other words, we're going to have a firm supply curve like this, right, Q of P. Oh, I'm sorry, I should say the firm's long run supply curve. Right, since we're given, Q of P, right, which is just going to be basically the inverse marginal cost. Beautiful. So this is what we're trying to do. What this means is that ultimately, in order to find our supply curve, we're going to need two objects, right? We're going to need our marginal cost, and we're going to need our average total cost. And how are we going to find a marginal cost and average total cost? Well, in order to find those, we're going to need to find our overall cost, right? So we'll need our overall cost curve, C of Q, right? So that we can find our marginal cost as the derivative of C with respect to Q, and our average total cost as C divided by Q. Great. So what we need is C of Q, right? Step one, it's going to be to find C of Q. Great. Okay. So how are we going to do this? Well, we know in turn that C of Q is just going to be W times L of Q plus R times K of Q. We know W, we know R, so what I've got in blue here, right, are the two objects that we actually need to find first, right, our L of Q and our K of Q. If we know how much labor and how much capital we'll use to produce a certain amount of output, that will allow us, right, to figure out how much it costs to produce a certain amount of output. That will allow us to figure out how much output we'll decide to produce at any given set of prices. And then we'll have solved this problem. We'll be so proud of ourselves. We'll bask in glory for the rest of the day. Wonderful. Okay, so what do we do from here? How are we going to find our optimal L of Q and our optimal R of Q? I'm sorry, our optimal K of Q. Well, we're going to need to figure out the cheapest way of producing Q units of output, given that this is our production function, right, and these are our costs. So we're going to have two things, right? Basically have our isoquant, L and K, right? We're going to want to find our cheapest point on our isoquant. So what are these isoquants going to look like? What kind of production function do we have? Well, we know that Q equals the minimum of 3L and 2K minus 6, all to the 2/3, which is a horrible and ugly function, but it's got buried in there, right? So we could mess with this a little bit. We could say Q to the 3/2 plus 6 equals min of 3L and 2K. And now we're going to notice that this is starting to look very, very familiar, right? This is essentially going to be perfect complements, right? How do we know that it's perfect complements? Because we have a minimum, right? If 3L was greater than 2K, additional labor wouldn't do anything for us. If 2k was greater than 3L, additional capital wouldn't do anything for us. So we're going to have isoquants that are L-shaped like this, with a kink, given where 3L equals 2k. Right? This makes sense? And where q to the 3 halves plus 6 equals minimum of 3L and 2k. Great. Okay. So this is going to tell us that our optimal choice of labor and capital has to satisfy two conditions. The first is that 3L has to equal 2k. The second is that we need to have enough to produce the output we want. So we know basically, we've got our isoquant here, which we've already messed with. We know that 3L equals 2k, so we can say q to the 3 halves plus 6 equals the minimum of 3L and 3L, right? Replacing 2k with 3L, which is just equal to 3L. So we'll say that L is an equal q to the 3 halves over 3 plus 2. K is going to equal, right, by the same token is also equals 2k. So q to the 3 halves over 2 plus 3. Beautiful. And this means that our cost function here is going to be W, which is 30, times q to the 3 halves over 3 plus 2 plus 20 times q to the 3 halves over 2 plus 3. So this is going to be, right, 30 plus 2 is 60, 20 plus 3 is 60, it's going to be 120 plus 30 over 3 is 10, 20 over 2 is 10, so plus 20 q to the 3 halves. Beautiful. So now we know how much it costs to produce q units of output for any given value of q, right? We've gotten our first goal here, our intermediate goal. So what do we want to do from here? Well, from here, right, we're going to want to find our marginal cost, we're going to want to find our average total cost, right, so that we can find our supply term. So our marginal cost of Q is just derivative of C with respect to Q, right, which is the derivative of this thing. So derivative of 120 with respect to Q is 0, right? Derivative of 20Q to the 3 halves with respect to Q is going to be 3 halves times 20Q to the 1 half, right? So our marginal cost of Q is just going to equal 30Q to the 1 half. Make sense? Wonderful. Okay. And then how about our average total cost with respect to Q? Well, our average total cost is just going to be C of Q over Q, right? Which is going to be 120 over Q plus 20Q to the 3 halves over Q, so 20Q to the 1 half. Great. Okay, so now what do we do from here, now that we have our marginal cost and our average total cost? Well, we can think back to this graph, right? This picture we drew at the very beginning. What we see on this picture is that we need to do two things. The first is we need to find the lowest price at which this firm is going to find it worthwhile to produce at all, right? This is going to be, I'll call this P star. And this is going to be the price, right, where marginal cost is equal to average total cost. If marginal cost is above average total cost, it's going to be worthwhile to produce. But if marginal cost is below average total cost, then the best case scenario output is not going to produce enough value to justify keeping this firm open at all. So how are we going to find P star? Well, we want to find the price where marginal cost equals the average total cost. We can do this by setting marginal cost equal to average total cost and finding the optimal Q star, right, where that's going to be the case, right, the lowest quantity that we're ever going to produce. So we'll find Q star by saying MC of Q star equals ATC of Q star, right? So this will mean 30 times Q star to the 1 half equals 120 over Q star plus 20 times Q star to the 1 half. I should note, right, when we're writing down this equation, the reason I'm putting all these stars here this is only true for a specific quantity, right? This is not a general statement that's true for any particular value of Q. We're using this to find the specific value of Q where marginal cost equals average total cost. Okay, wonderful. So now I can solve this for Q, so I can say 10 Q star to 1/2 equals 120 over Q star, right? 10 Q star to the 3/2 equals 120. Q star to the 3/2 equals 12. Right? So then Q star is going to equal, horribly enough, 12 to the 2/3. Great. And then what's our price going to be when Q star equals 12 to the 2/3? Well, our price is going to be equal to the marginal cost at that quantity. Right? So P star is going to be 30 times 12 to the 2/3, all to the 1/2, which is going to be 30 times 12 to the 1/2. Make sense? Wonderful. Okay, so what we've said is basically if we have a price below 30 times 12 to the 1/2, it's not going to be worth it to produce any output at all. If we have a price above 30 times 12 to the 1/2, then we're going to want to produce where price equals marginal cost. So the last thing here is if P greater than or equal to 30 times 12 to the 1/2, then marginal cost equals price. Right? So then we'll say 30 times Q to the 1/2 equals P. Q is going to equal P over 30, the quantity squared. Make sense? Wonderful. So what's our final answer here? Well, it's going to be a piecewise function, right? We've just found the two chunks. We said if the price is high enough, it's going to be P over 30 squared. If the price is below that, it's going to be 0. Right? So our final answer is going to be Q of P equals, if P less than 30 times 12, really squished here, huh? 0, if P is less than 30 times 12 to the 1/2, and P over 30 squared, if P is greater than or equal to 30 times 12 to the 1/2. Great. Okay. Sounds good? Wonderful. Okay. So just as a recap, right, what did we do? In order to find our supply curve, we needed to first find our cost curve, right? Our cost is a function of Q, which we did by finding our optimal choice of L and K. Once we had our cost as a function of Q, we found our cost curves, right? Our marginal cost and our average total cost. We figured out the minimum price at which we're willing to produce any output by setting marginal cost equal to average total cost, solving for that quantity where marginal cost equals average total cost, and backing out the price from there. Once we had that, we inverted our marginal cost curve, right, to figure out, instead of having basically P as a function of Q, have Q as a function of P. This gave us our supply when we're producing anything. Okay, beautiful. I'll move aside so that you can look at the whole thing, even the swish part at the very end, and I will see you in class.